We want to solve and graph each inequality and then express the solution using interval notation. And we solve a linear inequality in the exact same way that we solve an equation, except when solving an inequality, if we multiply or divide by a negative number, we must reverse the inequality symbol. Looking at the first inequality, we have 2x plus 8 is greater than 16. So we want to isolate x on the left side of the inequality. So we need to undo this addition and then undo this multiplication here. So we'll start by undoing the addition, so we'll subtract 8 on both sides of the inequality. Simplifying, we have 2x, this would be 0, greater than 16 minus 8 would be positive 8. And again, 2x means 2 times x, so to undo this multiplication, we'll divide both sides by 2. Now we're dividing by a positive, therefore we do not reverse the inequality symbol. So when we simplify this, we'll have x is greater than positive 4. Now let's go ahead and graph this. Notice that 4 does not satisfy this inequality because 4 is not greater than 4. So to show positive 4 is not in this interval, we make an open point on positive 4, and the numbers greater than 4 would be to the right of positive 4, so we draw an arrow to the right. And as we continue to move right on the number line, we would be approaching positive infinity. And knowing this is going to help write the interval in interval notation. The interval is from 4 to infinity, not including 4. So in interval notation, we'll have 4 and infinity. And to show it does not include 4, we make a rounded parenthesis here. And then for infinity, we always use a rounded parenthesis. So now we've expressed the solution as an inequality, as a graph, and in interval notation. Let's take a look at a second example. Again, our goal is to isolate x on the left side of the inequality. Remember, these are connected by multiplication here. So we first want to undo this positive 4. Well, to undo positive 4, we can subtract 4 on both sides of the inequality. 4 minus 4 is 0, that's why we did that. So now we have negative 4x is greater than or equal to negative 2 minus 4 is negative 6. And again, because negative 4x means negative 4 times x, we'll have to divide both sides by negative 4 to solve for x. Now again, notice we're dividing by a negative, so we do have to reverse the inequality symbol. So on the left we have x, and then instead of greater than or equal to, we'll have less than or equal to, and then negative 6 divided by negative 4 would simplify to positive 3/2. And if it's helpful, we can convert this to a decimal. Remember, 3/2 means 3 divided by 2, which would be equal to 1.5. And again, looking at this interval, notice that 3/2 would satisfy this inequality because 3/2 is equal to 3/2. So when we plot 3/2 this time, we'll make a closed point, and 3/2 again is between 1 and 2. So let's say it's right here. So we'll make a closed point on 3/2. And then for the numbers less than 3/2, we'll make an arrow to the left. And again, as we move further and further left on the number line, we would be approaching negative infinity. So using interval notation, we have the interval from 3/2 to negative infinity, including 3/2. So we use negative infinity, 3/2, a rounded parenthesis on negative infinity. But to show that 3/2 is included in the interval, we make a square bracket around 3/2. So again, we have the solution expressed three ways: as an inequality, as a graph, and using interval notation. We'll take a look at more examples in the next video.